Guten Tag. In this video, I'm going to be showing you how to make a simple, easy, intuitive, and fun 2D platformer character controller in Godot 4. To start off, I'm going to go into Project Settings, Input Map, and add some inputs. I've already made two, being left movement and jumping. I'm going to add the last one, which will be right movement. Press Add, and then add in the keys that I want, which is going to be D for WASD, and right arrow for arrow keys, like so. Now I can add a new scene, inheriting from the character body 2D. Now if you have used an engine like Unity, you might know this as the kinematic body. And I'm going to call it player, with only one R. Then I'm going to add my sprite. Now, I've already made a testing sprite, but you can use basically any image you want. I'm going to use quick load, and I already have my player, which looks sort of like a little video game testing capsule thing. Now I'm going to add some collision, the collision shape 2D. I'm also going to make this one a capsule, but I would recommend using a capsule for non-capsule shaped sprites. Now for the last part, I'm going to add a camera. Just search for it like this. L there. My camera 2D. Going to zoom in by a factor of 4 because my character is pretty small. This is just how you can see. And enable position smoothing. Go into editor and turn on draw drag margin. In drag, I'm going to set these both to tick or enabled, and set this one to 0.8. So now if the player jumps, the character won't move. They move slightly, the camera also won't move. Now I'll use Ctrl S to save it under my player file. Now I can go in here and add a new script. It'll be the object empty, but you can use this. I prefer to use object empty. Now I'm going to start by declaring a few variables. I'm going to export var acceleration, and I'm going to make it 5. Export var again. This time it'll be max speed, and I'll make it 125. Export var again. This time we're going to make it friction, which will be 0.5, a decimal. Note that the closer friction is to 0, the faster the player will stop. I'm also going to make gravity, which will be 980, and jump force, which will be 250, I think. Let's go with that. Now declare a normal variable in input direction, and I'm just going to make this one 0. Also going to make another one which will be move speed, and I'm going to specifically make it a decimal because this colon thing that I'm using will suggest a specific type of variable, whether it be a float or an integer. This one will also want to be decimals, and so will my coyote time. And those last two are just game feel things, but they're quite useful and very important. I'm going to add func, will be physics process, and jump buffer will minus equals 1 plus delta. So coyote time I will do the same, like this, on the next line. Minus equals 1 plus delta. And using delta time will mean that it will count down even if the player is in laggy conditions. Now if is on floor, then the coyote time will be equal to 10, which is about 1/6 of a second. Else, then our velocity on the y-axis will be plus equals gravity times delta. Now if our input is action is pressed, specifically being jump, then our jump buffer will be equal to 20, which will be about 1/3 of a second. And now if our coyote time is greater than 0, and jump buffer is greater than 0, then velocity on the y-axis will be equal to negative jump force, like so, and then jump buffer will be equal to 0, and so will coyote time, just so we don't have any confusion. Now, input direction, in this case, not doing more if statements, take a break from them, will be equal to input dot get axis, which is a really useful function. It allows us to get a number from these values based on whether or not the player is pressing them. Now, if the input direction, which just means if it's not 0, then move speed, if I'm only going to use this one, is plus equals acceleration times input direction. Now, if else, then move speed will be asterisk or times equals friction. Also, move speed will be equal to clamp move speed to negative maximum speed, and then max speed again. And then velocity x-axis equals move speed. And we'll also call move and slide, like that. Press Ctrl S to save. Go to our testing scene and use this button here to instantiate the player, like so. Now you can see the player. Make sure we save, it's good practice. Press run. Now I have a fully functioning player. If I press space right before hitting the ground, it doesn't matter because of jump buffer, and I can technically jump even though I'm not standing on the ground. This will make your players feel well, and like the game actually is responding, because it might not feel that way, even if technically correct. But also we have a smooth camera that doesn't always move if you want to make minute adjustments to the player's position, and if you jump, the camera does not move, unless you're going up high somewhere, like this. Anyway, if you've enjoyed this, please subscribe and leave a like, and I'll also be putting the code in the description if you're having trouble. Anyway, good day and goodbye.